Okay, we're going to be talking about Chapter 1, Section 3, which is about segments, midpoints, and bisectors. So, definitions to begin with. A midpoint, on midpoint, a point on a segment that is equal distance from both endpoints. Let's practice. If we want to find the coordinate of the midpoint of segment RS. So first thing we need to do is we need to go find the distance between the 2 points. So we need to find the distance between R and S first. We need to find the length. We need to find its distance. So logically, the easiest way we can do this is just count them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the length between R and S, or the distance between R and S, is 11. Next thing we're going to do is divide by 2. So we're going to take that 11 and we're going to divide it by 2. When we divide it by 2, we're going to get 5.5. That does not mean that 5.5 is the midpoint. What that means is R is 5.5 spaces away from the midpoint, and S is also 5.5 spaces from the midpoint. So I need to go and count to find my 5.5 spaces away. When I go and do that, I'm going to have to count. This is 1 space, 2 spaces, 3 spaces, 4 spaces, 5 spaces, and this will be my half. That puts the midpoint right there at, what is that, 3.5? So 3.5 is the midpoint of RS. Okay, let's go look at another one to practice midpoint. We looked on the last section and we found out that these tick marks mean that these 2 segments are congruent. Well, this tells us that segment PM is going to be congruent to segment MQ. We know that from the little tick marks. So if we go over here and let's read our example now. If the coordinate of the midpoint of segment PQ on the number line is 3, go label. They told us midpoint is 3, and point P is at a -2. Find the coordinate of Q. Well, we know that this one is congruent to this one. They both have the same length from our definition. They both have the same length from our definition. So they're congruent. So we need to first find what's the length from here to here. How far is it from there to there? So we can go ahead and use our absolute value and subtract them, the difference of the absolute value. So we're going to do a -2 minus 3. And we're going to end up getting, we're going to add our opposite. So negative, we're basically saying -2 plus a -3, which is -5. And with absolute value, it makes everything positive, so we really have just 5. So the distance between these 2 points is 5. It would be the same over here because we know that these 2 segments are congruent. So if this one is 5, then this one's also got to have the length of 5. That doesn't mean 5 is our answer. What we need to do is we need to go and see what the point would be if I added that 5 to the 3, and that would give us at point 8. So the coordinate of Q would be 8. Okay, let's go look at a midpoint formula. This is our midpoint formula on the coordinate plane. So when you're doing this on a graph, on the coordinate plane, when you have to go plot the points, this is the formula you would use. and you do it twice. This is a separation. You do this one first, it gives you the x coordinate. Then you go and do your y's, and it gives you the y coordinate. So you can have your x and y for your midpoint. They are two separate ones. You don't combine them. So let's go look at our first problem. It says, find the coordinates of the midpoint of segment EF, where E is -2, 4, and F is 3, 1. Okay, and we know that these are our coordinates. This is our x and this is our y. And looking at our formula, we have x1 plus x2 divided by 2. This x1 and this x2 are just like names. All they are names, because when we go down here and look, we have two x's we're dealing with. We need to name them so we know what order to put them in. Think about thing 1 and thing 2 from Cat in the Hat. Can you tell the difference between thing 1 and thing 2? Only thing that tells the difference is the numbers on their shirts. So we need to decide which one of these we want to make thing 1 and which one we want to make thing 2. Because it doesn't matter which one's which, but we need to keep it straight, so we're going to go label them. So if we want to make E our thing 1, when we have our x and our y there, we're going to put the 1s with it. And then F can be our thing 2, so we're going to label those as our thing 2. When we do that, now we've got exactly everything we need to plug it exactly into our formula and not get any of the coordinates numbers switched. Guys, go label these until you get used to the formula. Label them so you know, because it's very easy to get the numbers switched when you're putting it in the distance formula or the midpoint formula. So now we're going to take this formula up there. My x1 is a -2, so I'm going to put a -2 plus my x2 is a 3 plus 3, and then I'm going to divide it by 2. I'm going to go and do this first because they're two separate things. If I do this, I have -2 plus 3 gives us 1, and 1 divided by 2 is 0.5. So there is my x coordinate on the part of my answer. Now I must go do the y part. My y1 is 4, and it says plus, and my y2 is 1. Then I divide it by 2. If I go add 4 plus 1, I get 5, and 5 divided by 2 will give me 2.5. So my midpoint coordinate is going to be 0.5 and 2.5. Let's go practice another one. Now when we look at this, what they gave us right here was E and F. E and F are the endpoints of this segment. So we were working with two endpoints. We had E was an endpoint and F was an endpoint. The next one we were going to go work with is a little bit different. It says M is the midpoint of line segment AB. If A is at the coordinates 3, 5, and M is at -2, 1, we want to find the coordinates of B. We cannot go plug this into our midpoint formula because a midpoint formula finds halfway between 2 points. Right here we wanted to find halfway between E and F. We had line E and F. They asked us to find the midpoint. They wanted us to find halfway between those two. If we come over here, we have line, it tells us A, B, right here. They gave us the coordinates for A. They also gave us the coordinates for the what? They gave us the midpoint right there. These are the two that we have. If I used my formula, what I would actually be doing is finding halfway between those 2 points, A and M, and that's not what it's asking us for. It wants us to find what is B. So the way we can do it, one way we can do it is we can go ahead and think of it. This is my A, here's my M, which is my midpoint, and here's my B. Remember, if it's a midpoint, These are congruent. They are equal distance. They are equal. So my coordinates for my x and my y, because I'm going to do them separate, my coordinates for x is 3, and my coordinates for y is 5. On the midpoint, my coordinates for the midpoint is 2 and 1. Remember, they're equal distance. So if I look at this right here, if I'm at 3 and I'm going to a -2, how am I getting there? You can go ahead and think of a number line. This is -2, -1, 0, 1, 2, and 3. What is the distance between a -2 and a 3? We can count it, or you can think of it as the absolute value like we did, or you can look at it this way. How far is 3 away from 0? It's how many spaces? 3 spaces. And how far is 2 away, or -2 away from 0? It's 2 spaces. So I know that if I add those two numbers together, I would get 5. So I know I'm using a 5. Looking at this, I've got to decide, am I going to add that 5 or subtract that 5 to get to a -2? If I added 3 plus 5, I would get 8. If I subtract 3 minus 5, I should get a -2. That tells me I have to do the same thing with this -2. So I'm going to take that -5, come down here and do the same thing. What is a -2 minus 5? -2 minus 5 should give us a -7. This is my x coordinate on my answer. That is the x. We still have to find the y. Same thing. I can come over here and think. If I'm at 5, how am I getting to 1? What number could I put in there and add or subtract to get to 1? 5 minus 4 is 1. I have to do the same thing to the 1 in order to get our answer. So 1 minus 4 gives us a -3. Now I have the coordinates for B. B is going to be at a -7, -3. Woo! We're almost done. Okay, segment bisector. Let's go through definition first. Segment bisector is a line segment, or a ray that intersects a segment at its midpoint. Okay, we're using this word bisector. If we go and think about English and think about the way that we break words down, we know the term bi, like a bicycle. Bicycle has 2 wheels. Bi is going to mean the number 2, like a bike. Like a bicycle has 2 wheels. Over here, sect. Sect actually means to cut. Now, if we put this together, what this is actually telling us, the word bisect is actually to cut into 2 equal parts. If that helps you to remember, to cut into 2 equal parts. Let's practice. They tell us right here that segment WY comes in and bisects, which means it cuts UV into 2 equal parts at Y. So essentially Y becomes the, if you want to label until you get this in your mind, Y becomes the midpoint. And we know that we cut this into 2 equal parts, so we can go ahead and put our tick marks because these two would be equal. UY is going to be congruent to YV. And they tell us right here when we go to label that UY is 5. What do we know about our tick marks? If UY is 5, we just said that they were congruent, then YV must also be 5. So if I went over here and labeled YV is 5, so UV, the whole thing, is going to be 10. Let's practice one more. Our last one. Yay! Okay. Same thing. Same information we just used up there. So basically we know that Y is still our midpoint, and we know that these two are congruent. And that means, from our definition, we said that they are congruent. What did we say yesterday about it? If they are congruent, I mean, if they're congruent, it's what? Congruent segments mean that they have the same length. So we know that the length of U, Y, and YV are going to be equal. Let's go label. UY is 4x minus 3, and YV is x. We have to find some sort of equation that we can make so we can solve for x. Well, these tick marks tell us that they're congruent. Definition tells us since they're congruent, they have the same length. If they have the same length, these two segments are equal. There's our equation right there. This is the midpoint, cutting it in exactly half. So these two segments would be equal. So 4x minus 3 equals x. Then we have just algebra to go and solve to find out what x is, to plug it back in, to answer the question like it asked. 1 minus 4 is a negative 3x, and over here we have a negative 3. Our last step would be to divide, and when we do that we get x equals 1. It asks us to plug it in and find them. So if I come up here, we know this one is just going to be 1, and logically, we already know these are equal, we better get a 1 over here when we plug it in. 4 times 1 minus 3 is going to give us a 1. So the length of both of them is 1. Yay, we're done.